look at, or was it just that one? Yeah, what else? Number 12. Yeah.
I have trouble with all of them.
All of them. Okay. So maybe I'll start with the ones that other people are listing, and then if like you're still feeling stuck, then let me know. Is that cool? Yeah.
22B.
22B. Whoops. Okay. And is that yeah?
Can we do 1?
Number 1. Sure. Okay. Oh, was that a hand or was that a?
I know I realized mathematically or by myself.
Got it. Okay, well that's a good fix. I am also going to let you know that sometimes the way that things kind of work out, it ends up that we're going to go over that stuff today. So I'm going to look through these as we're looking through, and I might just say, oh, we're going to do one like that today, okay? And so I might not go through every single one of these, but my guess is that by the end of the day today, you'll feel good about everything. Is that fair? Okay, so don't think that I'm just ignoring you or that I don't like it. Nothing like that. It's just like trying to be efficient. Today is going over lots of problems day, so we will do that. So that all said, you should all probably have a book out too if you don't already. We're going to pull this out. I'm just going to kind of peek through these questions, and like I said, we'll go through a few of them, and then we're going to just work on a bunch of problems too today. Number 1. So I'm going to go in numerical order. Number 1 says, on the graph, what is the total distance traveled during the recorded time interval? What is the displacement? Okay, so we haven't really talked about distance and displacement, have we? Why don't you pull your notes out too? Can you have both your homework out kind of maybe on the side or know where to flip to? And let's pull our notes out as well. We're going to go ahead and define things because this was actually the first thing we were going to do today. So that works out very nicely. Sweet. Here we go. Some definitions here. Distance and displacement. If you ask random person on the street what the distance is, what is distance, and ask another random person on the street what is displacement, you might get the same answer. Because to random people on the street, they're going to say it was about the same thing. But in physics, we're very, very specific about the difference. What do you think distance means? Random person in my physics class? Yeah.
How far you travel.
How far you travel, right? I'm going to take the U out of it and say an object. Is that okay?
Yeah.
Okay. So I'm going to say how far an object travels. So that would be like the odometer in a car. Do you guys know what an odometer is? The thing that like click, click, clicks the miles. Or like a pedometer, if you've ever seen one of those, that like counts your steps, right? So how far did you go that day, for example? What is distance measured in? What units would we measure it in physics?
Meters.
In meters, yes. Okay. Life is good? You guys have a sense of what that looks like? Displacement. Have you heard the word displacement before? Yeah? Maybe in science class? Where have you heard it? Can you give me a definition or an example of displacement? Lizzie looks really excited to speak.
The only thing I can think of is the displacement method when we were trying to find volume.
Yes, so tell me about the displacement method. Do you guys know what she's talking about?
No.
Okay, well, so I want her to tell me anyway, so we're going to learn. Sweet, go!
It's where you have like irregular objects that you can't like measure the volumes, like length, width, and height. So you have like water in a beaker or whatever, and you put the object in it and you measure like how far up the water went.
Does that kind of sound familiar? Does that make sense to you? So you have like a graduated cylinder, a beaker, or something with some water in it, and maybe the water is at, I don't know, a certain number of milliliters, 15 milliliters, and then you plop the thing in, and then the water level rises, as would make sense, right? Because some of the water has been displaced, right? And so the water level goes up from 15 to 23, okay? And so then you can figure out, in this case, the volume of the object based on that, right? So the definition of displacement in physics is related but not quite the about water levels rising. I'm talking about an object moving. So here's my object. It starts out here, and I let it go, whoa, and it goes down there. Has it been displaced?
Yes.
Yes. What would displacement mean in this case?
How far it is at the start from the end.
Right, exactly. It started out here, it ended there. So could we measure that?
Yeah.
Sure. Now, do we know what happened to the frog in between?
No, it fell down.
You watched it fall down, right?
Yeah.
But let's say I had you close your eyes. Okay, ready? Everybody close your eyes. I'm going to start at the same spot, and it ends at the same spot. Do you know what happened to the frog?
No.
No. Did anybody peek?
Yeah.
Oh! What happened to the frog, peeker?
Went up and then dropped it.
You must have peeked too, since you were like, yeah, so those peekers, cheaters, they watched it went up and then back down. But for those of you that are honest children, that had your eyes closed and didn't peek, would you have had any idea that happened? No. And that's okay. Displacement has nothing to do with where the object went in between. It could have flied around the room and then done circles around his head, and we wouldn't have any idea. And not only do we not even know, we don't care. That's the thing about it. All we care about is where it starts and where it ends. Okay? So the displacement is the difference in position from, let's see, what am I going to say? One moment. This is kind of ugly. Hold on. I'm gonna change it. I don't have notes that I do this all kind of from my brain. So sometimes they're not very pretty definitions. So it's not like I'm getting them from the book. So I'm just gonna let you know that. So let's say the change. I'm gonna say change in position. This is why I like pencils, right? Because pencils erase like this does. Yeah. So we'll say change in position of an object. We're just gonna leave it there. The path doesn't matter. Okay. How would we measure displacement?
The easiest way is to measure a straight line from the starting place to the end.
It's a perfect way to do it. Start and get a ruler, boom, you're done, right? Or get a piece of string, boom, you're done. Absolutely. What are we measuring the displacement in? What units? Meters. Okay? Of these two, in physics, most of the time, we're going to talk about displacement. Okay? Most of the time, we're going to talk about displacement. Are we okay with those definitions? I'm going to look back at question number 1 from the homework now. So is this okay that I'm kind of bouncing back and forth? Okay? Because then it seems more organic to me. All right. So looking at this graph, everybody seeing the graph on page 69? So the object starts at a position of what? 1. And it ends at a position of 6 meters in some direction. Okay? We don't know what direction, but it kind of doesn't matter, I guess, in this case. So what was it? How far did it go? 5 meters, right? How far did it go? That's the distance it traveled was 5 meters. What was the change in position from the beginning to the end? 5 meters. Okay? What's the difference there? I would say that the difference is, and this is the key that I haven't written down yet, that displacement includes direction. Okay? Displacement includes direction. So the answer that I would give for number 1 for the displacement would be positive 5 meters. Okay? Yeah?
For distance, why wouldn't it be 6 if it ends at, not for displacement, but for distance?
Okay? Because it starts at 1.
Okay.
Does that make sense?
Yes.
Okay, good question, good question. Let me ask you a question to see if this is kind of sitting okay. Let's say that I'm telling you a story about my day, and I wake up in my bed, so that's good. It's a good way to start a day, I guess, right? As opposed to like waking up in some random place. Woke up in my bed, got ready to go to school. I came to school. I drove to West Des Moines, and then I drove to Ankeny, and then I went home. And then I got in my bed, and I fell asleep. It's a good story, right? Yeah, that was a good story. Tell me about my displacement for the day. Zero. Why?
You went back to the start.
Yeah, I started in my bed, and I got back to my bed. Tell me about my distance. Is my distance zero? No. I went a lot of places, right? But then I got back home, so my pedometer or my odometer or my whatever, counting my distance is going to be something interesting, but my displacement is zero. If I'm sick at home in bed, and I'm really sick, like really sick, then my displacement and my distance might be the same for a whole day. But probably no other reason would you ever have the same. You know what I'm saying there in that case? Okay. Another question. Let's say that I am looking for a buried treasure. That sounds like fun, right? That sounds like a way, way fun thing to do. And Katie knows where it is. And I'm like, give me a hint, give me a hint, give me a hint. She says, okay. You're gonna give me a hint, are you? She's thinking about it. Come on, we're friends. She's like, okay. So the hint that I'm going to tell you what the hint is that you're going to tell me. Or maybe I'm going to give her a hint. Anyway, whatever. So the hint is that it is 4 miles away. Is that a very helpful hint?
Nope.
I mean, it limits the amount of places that I could look from an infinite number to an infinite number. So, I don't know, I mean, it's a smaller infinite number, but if it's 4 miles away, it could be 4 miles that way, or that way, or that way. You see what I'm saying?
But that way.
Or that way, or that way. I don't know where it is. Or that way, right? There are a lot of choices. She told me the distance. The distance is not super helpful. But Lizzie's looking out for me. She talked to Katie and was like, hey, tell me where it is. And then she comes up and says, actually, Miss Curling, and no more information. The treasure is 4 miles away, directly south. Now can I find it?
Yeah.
Absolutely. I know the distance that it is, and I also know what? The direction. That's the key. The direction tells me so much information. Hold on just a second, Amy. Let me finish this little spiel, okay? The magnitude or the size and the direction tell me everything. If you have a size and a direction, we have this thing called a, does anybody know?
Vector.
A vector. Yeah, right? It's this beautiful cultural reference. A vector is a measurement that includes, I always mean to get a clip. I always want to have that little video clip because it's so cute. But can somebody tell me what he's going to say?
Direction and magnitude.
Love it. I hadn't seen that movie when it came out and people started referencing it. I'm like, what? So I had to watch it. It was 2. And I was like, I have to see this. It's good. Yes, direction and magnitude. Everybody cool with that? Okay. Displacement is a vector. We mark it in your book. I think they read it as delta x, right? Am I right there? Or am I making that up? Yes, it is delta x. I'm going to put a little arrow on top of it. That arrow means it is a vector, right? Okay, that's the thing. That's the key. Okay, I answered question number 1. Go me. Let's look at number 12. And again, I may fill in other things as we go. Number 12. Is that okay? Is everybody okay with number 1? Okay. Number 12. 2 cars are traveling on a desert road as shown. Oh yeah, the picture in this one is kind of confusing. Yeah? I don't know why. I think like if they just continued the picture so it was 2 pictures instead of 1, life would be perfect. If you just read it that way, then you're happy. But let's keep talking. 2 cars are traveling on a desert road as shown. After 5 seconds, they are side by side at the next telephone pole. The distance between the poles is 70 meters. Identify the following quantities. So on that one, if you, instead of having that break in between picture A and picture B, just continued it on, would it make more sense to you?
Yeah.
Okay. Does that kind of get you where you need to go? Do you want me to say more, or does that say, yes, say more? Okay. So part A says, the displacement of car A after 5 seconds. So in picture A, car A is sitting at that second telephone pole. Is everybody cool with that? Okay. And then in picture B, it's at the next telephone pole. So how far has it gone? 1 telephone pole length. But we know that each telephone pole length is how many meters? 70. Is that a little bit better? Okay. So then part B is probably okay. And then part C says the average. Oh, here's a new word for us. Yay, back to our notes. Distance and displacement. Then we've got these 2 other words that are also important. Speed and velocity. Again, if you went and talked to people on the street and said, hey, tell me a definition for speed, and then asked another person, hey, tell me a different definition for velocity, they'd probably tell you the same thing, unless they take physics. Okay? Because there's a subtle difference. What is speed? What's that?
Distance and time.
Distance and time, like added together?
Divided. Distance
Divided by time, right? Okay, so speed is equal to, whoa, hi there. The distance you've traveled divided by the time in which you did it, right? The units here, distance is measured in?
Meters.
Time is measured in?
Seconds.
There you go. So the units would be meters per second. Are we okay with that? Okay. But distance is it a vector?
No.
No. Do you know what the opposite of a vector is? What did you say?
Vector.
Good guess. Wrong answer. Sorry. It's actually called a scalar. Scalar. It's kind of a funny word. So a scalar is a measurement with no direction. It's like it needs to go see a counselor. Like, I have no direction. Right? No, it just doesn't. That's not a specified piece. Okay. So like your height is a scalar. A temperature is a scalar. Okay. Distance is a scalar. That treasure is 4 meters away. Okay. I don't know where. Speed is also a scalar. Say it because it's cool to say.
Scalar.
There you go. It's a scalar. We get this. We use this. You've done this a lot. Andy, I was going to call on you before. I'm sorry. What's up?
I was just going to say, even if they tell you that the treasure is 4 miles south, there's still an infinite arc that it could be upon.
No, south, like on this plane. So in 3-dimensional space, you've got north, south, east, west, and then up and down. So if it's directly south, then there would be 1 point. Does that make sense?
Fair.
Good thinking, but I disagree. Is that fair?
Yeah.
Okay. All right. So speed, easy enough. We've been doing that for a long time. Velocity is just a little bit different. Velocity, we're going to mark velocity with a V. It is a vector, so I'm going to put the little arrow on top of it. And velocity, instead of being equal to distance over time, it's equal to displacement. So it's the one that has direction, right? So it's displacement, that delta x business. Over time. Okay? What are the units of velocity? It's not a trick question. Meters over seconds, right? This is still in meters, this is still in seconds. So it's in meters per second, but you need to have a direction that goes with it. That's the difference. So we've got that? Life is happy? Awesome. Okay, now we're going to answer question 12, part C. The average velocity of car A during the 5 seconds. So what was the distance or the displacement of car A during those 5 seconds? 70 meters. And how long did it travel? 5 seconds. So the velocity is going to be the displacement of 70 divided by the time of 5, which would give us 14 meters per second. Is that okay? And then you're like, well, what direction? It's not quite that cranky, this chapter, so don't worry about it too much. Just Are we okay? Can I cross 12 off the list? Awesome. Look at us moving so fast. 22B. 22B, I'm going to wait on. And the reason I say that is because we are going to do some other problems like that in just a couple of minutes. Is that okay? So I'm gonna like we'll get to that one, or we'll get to knowledge so that you can do that one. If you go home this weekend and try number 22B if you didn't get it before, and still are stuck on it, then let me know on Wednesday when I see you again, and we'll go over it. Does that make sense? Is that fair to everybody? Okay. And then 29. I don't know what 29 is. Same thing with 29. So 22B and 29, we're going to go through a bunch of stuff that will look like it. So try it again this weekend, okay? Fair? Okay. All right. Now that we just did all of that, I want to look and see where I want to jump in next. 40. Okay. This is what I would like to do right now. I would like for you to work on a problem with your partners. So part of this opportunity is to get to know your partners. Part of this opportunity is to get our brains into solving these problems. I would like for you to turn to page 44. And I would like you to try and solve number 2 on page 44. I want you to work with that person you're sitting next to. I want you to have paper out. I want you to work on it. Work as a trio, or Lizzie, if you want to go, if you guys want to be partners, you could do that as well. That's fine. Either way is good.
That way.
All right, give that one a try. That's okay. I didn't give you a whole lot of time. But even if you think you're finished, I'm going to argue you might not be. And the reason I say that is because I want you to write up problems in a very specific way. Okay? This question, number 2 on page 44, is not a very hard problem. But by the time we're finished today, in 45 minutes, we're going to be working on some problems that are pretty tough. And if you don't start doing this process, those problems are going to be very tough, okay? I will say this a bunch of times to you. I've taught this class a lot, and I've brought my 9th graders through to do pretty hard stuff, but you have to play with me the way that I'm telling you, okay? And you can do it. Does that make sense? Okay? So make sure that you're showing work. Make sure that you're showing work appropriately. So, you've read the question a little bit, right? Joe, he's riding his bicycle in a straight line for 15 minutes with an average speed, blah, blah, blah. Yes? Okay? The very first thing I want you to do on every problem is to write down a list of givens. Okay? Every time, always. So I'm going to do this with you. Here we go. Here's our list of givens. We're going to read through the problem and see what we see. And see what it might represent. Raise your hand if you can tell me something that we see in there. Some sort of numeric. Oh, look at these hands. I love this. Go. Oh, I want this one. I want to share the fun.
Okay. It's 15 minutes.
What is 15 minutes?
His ride.
His ride. So it takes 15 minutes. If I was going to say 15 is equal to something, without my computer being totally ridiculous, stop. There we go. What would I say the 15 minutes is equal to? Anybody? Go ahead. Time. Yeah, that's what I'm going to say. Is that okay? And that's just looking at the units? This is all about looking at units and figuring out what kind of measurement we're making. Something else?
The speed is 12.5 kilometers per hour.
Yeah, and I'm going to go ahead and write that as a V because velocity and speed are kind of interchangeable. Is that okay? So, and you said that it was what?
12.5 kilometers per hour.
12.5 kilometers per hour. Are we okay?
Yeah.
And then in the list of givens, I'm also going to put the thing I don't know. So what is the thing that I'm looking for or that I'm trying to find?
Distance.
The distance. And I'm going to write the distance as delta x. Okay? The reason that I want you to do this is that once you have this, we have a relationship between these three things, don't we?
Yeah.
We just wrote it down. What was it? Anybody?
Velocity equals displacement over time.
Yeah. And I'm not going to get really picky right now about velocity versus speed and distance versus displacement, but I think in this question, because I guess it doesn't really say, so I'm not going to worry about it in this one. So is everybody okay with this process so far? Okay? Now, once I've written my givens down and once I've written my equation, I need to solve this equation for the thing I'm looking for. What am I looking for?
Delta X. Delta X.
Delta x. Now, you've all had Algebra 1 at least, correct?
Yes.
Yeah.
Yes, you're all in Geometry Algebra 2, something like this?
Yeah.
Or maybe above, maybe you're like in Calculus BC, I don't know. But you've at least had Algebra 1. So we know how to get that TL by itself, don't we?
Yeah.
How do you get the TL by itself?
Delta XL by itself.
Or sorry, delta XL by itself. I was kind of giving it away. Oops. How do I get the delta XL by itself?
Multiply both sides by t.
Multiply both sides by t. Sorry to spoil that. I'll try not to spoil it in the future. Is that okay with everybody? And I can do that without putting any numbers in. Yay! We don't want to put numbers in until the end. Now, I want to put numbers in now because I'm ready. Is there anything else I need to do before I put numbers in? Can I just put a 15 and 12.5 in and be happy? No, what's wrong? What's wrong, Bridget?
The time for velocity is measured in hours,
Okay.
and the actual time is measured in minutes. So you either have to convert one to minutes or the other one to hours.
It's true. Or you can convert them both to seconds. That sounds like a lot of work. I don't want to do that. Let's convert one or the other. I'm thinking converting this is going to be pretty easy, right? 15 minutes is how much of an hour?
1/4.
1/4, 0.25. So that's super easy. Let's do it. So this is 0.25 hours. And now I've got things with units that are happy. Is everybody cool with that? Yeah? Stop me if it doesn't make sense. So now I'm going to do 0.25 hours times 12.5 kilometers per hour, and that's going to give me the displacement. I want you to plug the units in every time. I know that it seems kind of silly maybe, because this problem is pretty straightforward, right? But I want you to do this because, as I said, soon they're not going to be this easy. If we put the units in, we've got an hours on the top and an hours on the bottom. What happened to those hours? They canceled. Yay, see you later. I had a good friend in college when we would do like really nasty, big, scary equations, but then all the units would cancel, and every time he'd be like, splat! And I'd make fun of him. But if it makes you happy to say something like that, then do it. Because it's gonna, like, it's just gonna, yeah. So maybe I'll bring back Ben's splat, because he liked it. All right, so now we're just gonna multiply 0.25 times 12 and a half. What is it? Did you do it? If you don't have a calculator out yet, you probably want to get one out. Do you have an answer?
Yeah.
Okay, hold on just a second. I want everybody to get an answer, and then I'll let you tell me. Is that fair?
Just, yeah. I expect to the calculator.
All right. What did we get? What did we get? What did we get? Answer? Answer. Answer.
3.125 kilometers.
3 point what?
125.
Do you agree? 3.125. Now, there is going to be one thing that I'm going to be a little cranky about because we just learned it, and we don't want to ignore things that we just learned. What am I going to be a little cranky about there? The meters, like, maybe, yeah, I could. That I'm not super cranky about. If the problem gives something to you in kilometers, this what is it, though? Esmar, go ahead. Yeah, sig figs. That's the thing. I'm like, a little bit. How many significant figures do I have in my time? 2. How many do I have in my speed? 3. If I have 2 here and 3 here, how many do I get here? 2. Just 2. So if I was going to write this with correct significant figures, how many significant figures do I get? 2. Sorry, I just asked you that question. You guys are wonderful to answer it twice. What's the right answer? That's what I meant to say.
3.1 kilometers.
Just 3.1. 3.1. I love it. Are you okay? Yeah? Do number 4. Do number 4 real quick. I want you to set it up like this. I want you to show me this work. Go, go, go. And then we'll make it a little more fun. What's up? Does that make sense? What's your deal? Just do one. Oh, I'm sorry. I was going to write the next one up. My bad. Did you want to watch this one? What's up? Hold on, just, yeah. Was it, yeah, okay, yeah. Okay. No, so So it would be 6, 9, well, okay, so it's like, first of all, this is not quite right. But if it was, okay, so that, okay, and then I'll tell you what's going on. If it was, right, then it just was 6, 9, lowest number is 6, 9, 1, 6, the algebra here does. So when you, generally what I would do is, you want to, I would move the T over here first. Yeah. Does that make sense? Yeah. How did we do? Is there anybody that is stuck, confused with algebra? Yeah? Algebra? Should we do algebra? Yes, ma'am. Okay, so let's, yeah. Ladies and gentlemen, I'd like your attention up here, please. If you need help with the algebra, I'm going to go through that right now. If you got it, just sit tight for a minute. Don't talk super loud so that I can get through this. Does that make sense? Thank you. Okay, so let's go through it, and you'll get better at it the more you do it. I'm going to let you know there will be a lot of algebra in this class, especially in the first few chapters. Okay? So if algebra is not your favorite thing, we're going to need to kind of ramp it up. We're going to need to practice it. And I don't mean that like in a threatening way. I mean that in a, you guys are all exceedingly capable. But it's been a long summer, and you may not have done algebra every single day this summer, right? So we may just need to kind of get our brains back in there. If I ever skip steps and you're like, how'd that happen? Just ask and we'll go through it. Fair? So I'm going to go from here to there. I'm going to start from the original equation. I'm just going to write this down further so we can see it a little bit better. So V is equal to delta X over T. First of all, is everybody okay with that equation? Yes. And the fact that I said that. Okay, so now I want to get T all by itself. Two problems. Problem number 1, T is not by itself. And problem number 2, T is in the denominator. Oh no. Do we want T in the denominator? No. So I'm going to get rid of that first. I'm going to take care of that problem first, and then we'll deal with the rest of the issues. Okay? How do I get T out of the denominator? Right now I'm dividing by T. What am I going to do?
Multiply by T.
Does that make sense? Because those are inverses? Okay, that's good. So I'm just going to keep going through it with us. So we're going to multiply by T on both sides. So life is good. Everybody's happy still? So now I've got T times V is equal to delta X. One of my problems has gotten away, right? I'm not dividing anymore. But the other problem has not gone away because it's not by itself. Right now I'm multiplying T times V. How do I undo multiplying by V? Yeah. Divide by V. Does that make sense? Because again, it's the opposite. It's the inverse. So I'm going to divide by V. And I'm going to divide over here by V. And this is really gross because there's a whole lot of like crossing out. So I'm going to figure out what's left. So on the left-hand side, I'm left with a T. Is everybody cool with that? Yeah? And on the right-hand side, I'm left with a delta X on the top and a V on the bottom. So let's do it. Delta X on the top, V on the bottom. Is that okay? And then it's just a matter of plugging numbers in. Okay? I really want you to get in the habit of doing your algebra first. And the reason that I say that is because I can follow this a whole lot more easily than if there are numbers in here. With units in here, it gets really, really messy. And it's hard for you to figure out what you did, and it's hard for me to figure out what you did. So just wait until you have an equation solved and then plug numbers in. I guarantee it will make your life better. Right? It's kind of nice when you get guarantees like that. Like, this will make your life better. Right here. Boom. Secret to everything. Secret to happiness. Okay, are you okay with this now? Yes. Everybody's good. Okay, so now we're going to make it a little more fun. Because it is not often that you have an object that's actually moving at a constant speed. That's kind of boring. Usually things are doing what? Accelerating. They're speeding up or they're slowing down, right? So let's talk about that. We're going to accelerate. because we're in accelerated physics, so I guess we have to know what that means. Here we go. Acceleration. Acceleration is not a hard concept. It's marked with the letter A. And as we just kind of implied, acceleration means that what is changing? Your speed or your velocity. Yeah. So we're changing our velocity. Now, we had that delta. I think we talked about delta last time too, didn't we? And maybe even the time before that. Delta means change in, right? So delta V, so the change in V over some time interval. Okay? Now, some of you, if you're careful readers of the book, might say, but Miss Carmeling, in the book, they write a delta T here. Okay? I'll say, yes, they do. I'm lazy. And to me, the time elapsed means the difference between the time that my watch says now and the time that my watch says now. Do you see what I'm saying? Okay? So I'm just going to call it the time elapsed. And then I don't have to write that delta sign. That's all. If you like it, do it. I'm not going to stop you. Okay? But I'm just not going to write it. Everybody's cool with that? We could also write, because change in just means final minus initial, we can write this as the final velocity minus the initial velocity divided by the time. And that's okay as well. Either one is fine. Okay? And then maybe we can try a problem with that. Can we try that? Yeah. What was that? Was that a no or a whoa or a what? No. Oh, well, too bad. Page 49. Page 49. I would like for you, with your partners, to try number 2 on page 49. It's the same kind of process. Same kind of process. You're going to start by writing down your whats? Absolutely, every time. And the reason for that is not because I am and it's not because I'm just like it's because the problems are going to get hard in the balance. And
then what you do?
Right. So wait for 5 minutes. And it's a little. Perhaps you and even if you think that's the way you still do it, because soon it's going to be. After you graduate from high school. Oh, like on last time? Right.
Like, say where does it say, like,
Then you'll lose points.
there were a bunch of, like, hilarious.
So start doing it now. What's up?
So, if you have 12
I will read it.
I remember a really.
Sorry, I had to be cautious. Okay, friends, how are we doing on this problem?
Good.
Are you done or do you need another moment? Okay, I'm going to keep writing. You keep going too. Okay. I want to grab your attention up here, if I may, just to clarify a couple of things. First of all, did this go okay?
Yeah.
Okay. If you're saying no, I'm going to get to that answer in just a second. Is that okay? This is the answer that I got. That's supposed to be a 2, although it doesn't really look like a 2. There, that's a little bit better. If you are on the, so everybody lives on a spectrum of understanding and being able to write things out, right? Okay. If you're living on the part of the spectrum where you really don't feel like you need to write things out, this is the minimum amount of work that I'm looking for. Okay? I was just talking to a couple of people as I was walking by. When you do a problem for me, like on a test or on a problem set, generally problems are worth 4 points. 1 point for the givens. Check. 1 point for the original equation. Check. 1 point for the work, and 1 point for the answer with units. Okay? That's what I'm looking for. So if this stuff is easy for you and you can just see it and it goes, then this is what I would need to see. If you are not as comfortable with the algebra and you need to do it step by step like I did up there with that orange one before, that is absolutely fine. I would never take points off for having more work than the minimum, okay? But you have to have at least this much. Does that make sense? Yes.
Would it be kind of wrong if we just put 2 seconds, not 2.0 seconds?
So that's a sig fig problem, right? So generally what I do is I would take points off 1 time for that. But I would, like, so if there were 3 questions and you did the significant figures wrong on all 3 of them, I could only lose 1 point. Does that make sense? Because otherwise I feel like that's kind of being, so, yeah. But it does need to have just 2 significant figures, and but it has to have 2, because these guys both have 2 and that one has 3. Okay? And I think we kind of talked about that a little bit last time too, so we'll get into that. I'm going to go here and then here. Go ahead.
For our homework for the last 2 chapters, if we don't have that, do we still need to go back and
So here's my answer for that. If you haven't done that so far, I'm not going to worry about it. But from tonight on, does everybody catch that? From tonight on, I'm looking at this. Because I didn't tell you before, right? That's kind of like me. So no, from that 3rd set of homework on, I'm looking for this stuff. I'm going to go here and then back there. Or was that your question?
That was my question.
Sweet, okay. Andy, go.
would you also take a point off if we had too many sig figs?
Yes. Yes. The same point. So if you had too many one time and too few one time, it would still only be 1 point off. Okay, I don't want to yeah. There's 1 significant figures point. It exists. Or it doesn't, depending on if you lose it, I guess. Okay, so I'm guessing if we're stuck, that the issue is getting from here to here. Is that true? Okay, so can I help people there? So let's do that real quick. The algebra is very similar to what we did last time. But again, if you haven't done this for a while, then you're probably going, oh, I haven't done this for a long time. Let me try again. Okay, so if we have A, come back to me. There we go. A is equal to VF minus VI over T. We want to get T all by itself and in the numerator. So let's get it in the numerator first. So how do I get it out of the denominator? Multiply by T. Now it's not in the denominator anymore. Yay, team! But it's still being multiplied by something. So I need to undo the multiplication by dividing. Okay? And again, the more you practice with this, the easier it's going to be. So we've got T is now equal to VF minus VI over A. Does that get folks that were unsure before where we're needing to be? Excuse me. Okay. So, in these conversations that we've had so far, we've talked about displacement, velocity, and acceleration, and time, yeah? And we know that if things are accelerating, that there are actually two velocities. So we've really got acceleration, I'll go in a different order here. Acceleration, time, displacement, initial velocity, final velocity. Really 5 things, okay? How many of those 5 things exist in this equation? 4 of them. Which one is missing? The displacement. If I wanted to know the displacement, could I use this equation? No. I'd be so sad. We need a new equation, right? There are 5 things, and there are nice equations that give us ways to relate 4 of those 5 at all times. Okay? I'm not going to spend time what we call deriving those equations. Deriving means like showing you where they come from. It really does not take a long time. And if you're curious, let me know. You can come in sometime for like a 10-minute discussion. We'll go through it because it doesn't really take very long. I just would rather spend time today in class practicing with the equations. Does that make sense? So that's what we're going to do today. I also gave you this purple sheet so that you can have access to this at all times. Okay, this is the equation sheet that you will use for this semester. We will not go through all of this material. This is just all of the stuff that we could go through. Okay, because different semesters I do different amounts of things. Right now, I want you to put your name on it. The name is on the side. Go ahead and do that right now. I have a copy of this available on Dropbox, which is available through the Infinite Campus newsletter. If you don't have access to that, send me an email and I'll get you access to it, okay? But this is there, so if you lose this copy, go print yourself a new one. Yay, you always have one. You will have access to a copy of this for every test, okay? It's laminated, and you don't get to write on it. Do you know what I'm saying? But this is exactly what it looks like. I think it's on a little bit lighter purple paper, but it's the same thing. It's even purple still, okay? So you want to get to know this. I would use this. I would like hold on to this. Love it. Okay? Know where stuff is so that you don't forget. And don't put it away yet because we're going to use it right now. We're looking at the top left-hand corner box. You see it? It says Kinematics and Motion chapters 1 and 2. Hey, that's what we're in. Go us. If you want to write on here to remind yourself of stuff, that's great. Please do. Okay? That very first equation, V average. Do you all know how to take an average? Yes. So if you're taking an average of 2 numbers, you add them together, divide by 2, right? That's all this is. If you're finding an average velocity, let me say one thing real quick, and then I'll answer your question. If you're taking an average, like, so you start at a speed, like, I don't know, maybe what was it, 7, and then you end up at a velocity of 12 meters per second, you could figure out the average, right? What's 12 plus 7? 19. Divided by 2 is? 9.5. So that would be your average velocity, okay? Overall, you went about 9.5 meters per second. Question?
So,
is it about another equation?
No, I'm looking at that, and what's VF and VI?
VF is the final velocity, so that's how, like, so if you're speeding up, that would be the biggest one.
Yeah.
And VI is initial. Yes. Yes. So if you want to write that in there, please do. Please feel free. You can write all over this. I don't care. Okay? Have you seen that second equation before? Yeah. That's the one that we did for velocity, right? You might want to write next to this. This is only true if there is no acceleration, or if acceleration is equal to 0. only true if acceleration is equal to 0. Skip that next one. Ooh, we'll get there in a second. The one right below it. So the 4th equation. Do you see that 4th equation there? Yeah. I'm going to write it down up here because it's important. Well, they're all important, but... So this says VF is equal to VI plus AT. The reason I want to write this one down is to show you something. A little algebra time. Here we go. What if I subtract VI from both sides? Do this with me.
VF minus VI
Yeah, you get VF minus VI.
equals A times T.
Right? And then what if I divide by T? Then you have the acceleration equation that we had before, right? The reason I wanted to show you that is that it's just the version with nothing in the denominator. Okay? That's all it is. It's just a non-denominator version of that equation. Okay? Those bottom 4 equations, I might put a box around those if I have my own sheet. I might put a box around those. Those are your 4 key equations. And in your notes, I'm going to have you write those down as well. I'm going to write this on my notes as kinematics equations. And I'm going to tell you what kinematics means because that's a big word. Does anybody know, using your word within a word skills, what does kinematics mean? Or what does kina mean? Yeah.
Connect or connect?
Not connect. It's close. It's a good idea. It's a good idea. Yeah.
Connected means motion.
Motion. Yeah. Yeah. So these equations are the equations of motion. That's all it is. It's just a fancy word. So your mom asks you, what did you learn today? I learned kinematics equations, right? Like that sounds way cooler than motion equations. So it's just make yourself fancy. Kinematics equations. I'm going to write them down. I want you to write them down as well. And you'll see why in just a minute, but I want you to have them in your notes also. So delta x, that's the displacement, is equal to 1/2 VF plus VI times T. The next one was VF is equal to VI plus AT. That's the one that we decided was actually the acceleration equation. We've got delta x is equal to VI times T plus 1/2. Hello! This one is so fun. It will become your best friend. It looks scary, right? Like, oh my gosh, there's a half, there's a square, no, it's going to be the best one. Trust me. I've done this for a while. It's so cool. And then VF squared is equal to VI squared plus 2A delta x. That's a lot of stuff. Look at everything you're learning today. This is awesome. Oh my gosh, I love it. Okay. So, if I was looking at these for the first time, like you very well may be, you're going, holy buckets, what am I doing today? This is crazy. This is a lot of stuff, yeah? But I want you to take a look at them. A lot of them have a VI in them. How many of them have a VI in them? Take a look.
All of them.
All of them. So that's not a big deal because you know what VI is, right? What is it?
Initial velocity.
Yeah. A lot of them have a VF in them. How many of them have a VF in them? 3 of them. How many of them have a T in them? 3. How many of them have an A in them? 3. And how many of them have a delta X in them? 3. Okay, so do you notice besides VI, the answer is 3 to everything, right? So there's something missing in each equation. Now, we're going to draw a little chart because I feel like it makes life easier for you all as you're getting used to this. This is why we like writing down our givens. This is the chart I would like for you to draw. It's going to have 1, columns. And it's going to have 1, 2, that's 3, 4, 5, hold on, let me count. 1, 2, 3, 4, 5, 6 rows. 1, 2, 3, 4, 5, 6 rows. Okay. So it's going to look something like this. And on the top row, I want you to label 1, 2, 3, and 4 in the far boxes. I'm going to label my equations 1, 2, 3, and 4. Are we okay so far? Yeah? And then going down this side here, we're going to make a list of those variables. Okay? A list of the possible variables. So I'm going to start with delta x. Oops, come back. Delta x. Let's do VI, VF, A, and T. I'm going to do one equation with you, and then I'll let you do the other ones on your own. Equation 1. I'm just going to put a check mark if it has that thing. Does equation 1 have a delta x in it?
Yeah.
It does. Does it have a VI?
Yes.
Does it have a VF?
Yes.
Does it have an A?
No.
Does it have a T?
Yes.
Okay. I want you to go through the other 3 equations. If you want to work with your partners, that's fine. But do it. I'm going to give you about a minute. You aren't really talking so much. I want you to check with your neighbors now, because it looks like most of you are done. See if your charts match.
Yeah, use the restroom.
Yeah.
Thanks.
All right. Does your chart match this? I didn't actually put my X's in, but these are where I'm missing things.
Yeah.
Are your missings matching this? Okay. So here's the game. And this is where people say this is the hardest part of chapter 2. Is figuring out which equation to use. Because instead of just having one equation, then it's easy, right? One equation, do it, boom. Now we have 4 and they're all really maybe scary looking. If you write down your givens and look at your givens and compare it to this chart, you're going to be all right, okay? Let's try it. I would like for you to turn in your book to page 55. And I would like you to look at number 2. You're not going to finish number 2 probably, but I want you to write down your givens. There are 2 parts to it. And I would like for you with your partners to figure out which equation you would use. Okay? Number 2, yep. velocity, or you can use them interchangeably. Yeah.
But it does give us a find the observation numbers.
It's not give us delta x or a variation.
So I put my givens up on the board and my question marks up on the board. So if you want to double check, you can do that. And now I'm going to look for equations too. I just wanted to let you know where I'm at if you want to double check. Keep going. Keep going.
I think it's wrong without a delta x because just because these you can find yeah, it might be reason. So I find one because
No, that's not what it's sine final speed.
And if you've chosen the equations and you're feeling comfortable with that, then go ahead and solve the problems. Go ahead and do it. Let's take a look. Awesome. So you've got your equation and your unknowns. Only thing that I'm missing is 6. Yep, but other than that, it looks great. Yeah, nice work. And is that for part, that's for A, right? Or I think it's not good. Yeah, and then I put some units there. Yep, good job. It actually has two questions. There are actually two questions kind of hidden in that problem, right? Because it asks for the final velocity and the displacement. So once you've found final velocity, go on and do displacement. And if you're just that fast, I'll give you another problem to work on because we don't want to waste time. That would be silly. If you're finished, then do number 4. Same page. I'll be right there. Hold on just a second.
Yeah. Check. So the answer I got was 5.9.0. 5.9.0. Okay. Yes. But I can only have two specific figures, so do I put the point 0 or not?
You do not.
So it's like 59 meters.
Exactly. Yep.
Now we're needing.
Again, if you finish number 2, try number
Okay, so now we've got those max.
Oops. Oh wait, 59. I put the answers up here just in case you're ready for them. I'm not trying to spoil anything, but there you go. Again, if you're finished, then move on to number 4. Go, go, go. Did you hit up? Or you just for part B, or for the second part? So I use the delta X VIT squared because that matches the thing I don't know and the three things I do know. No, this is for number 2. Are you on number 4? Yeah. Oh, I wrote that down yet. I'm gonna go answer a couple more questions and then I'll put that one up. Sorry.
So for something involved with
It's so if you look at so acceleration is change in velocity over time. So the units for velocity are right? And then dividing that by seconds. So if you just play with units, you're supposed to actually meters per second. So that's just it.
And if you work it out, it works out a little more simple.
Yeah, so it's just giving that number. It means that it's getting faster by that many meters per second every second. All right, ladies and gentlemen, hold on just a moment, please. In case you got number 4 finished and you wanted to double check your answers, the answer for part A, maybe, there's my A, is 2.5 seconds. And part B is 32 meters. If you didn't get there yet, that's fine. I want you to try the homework. Do your best. I'll answer questions again on Wednesday. And I hope you have a wonderful long weekend. If you have questions right now, I'm coming to help you in just a moment.